Welcome to 10-2, Solving Systems Using Substitution. I'm pretty sure some of you saw how in the previous lesson you could have substituted and solved that way. You may have recognized it. We're going to go through it in a little bit more detail here. This is a way to take a system, and if you can isolate one variable or the other and make it equal to something, then you can use that as a substitution. When we're in this y equals mx plus b form, it's pretty easy to see how we might do that. If we solve this system using substitution, we have that y equals 2x plus 8 and y equals a negative 5x minus 27. Well, these are the same y's, so if I know that y equals 2x plus 8, I can substitute 2x plus 8 for y. So I can then write that 2x plus 8, which equals y, equals a negative 5x minus 27. Now I solve this for x, the equation. I think I'm going to go ahead and add 5x to both sides of the equation. So it's going to be a plus 5x. I'm going to subtract 8 from both sides of the equation. That's plus 5x, and that's minus 8. I'm going to have my equal sign here. So that's going to be 0. 8 plus 8 minus 8 is 0. So 7x equals, this is 0, right? And 27 minus 8 will be a negative 35. Now I multiply both sides by 1/7. Seven over 7 is 1. I get that x equals 7 goes into a negative 35 and negative 5 times. So I have completed the first part of my journey. If x equals a negative 5, I need to substitute this value back into either one of the equations, and then I can solve for y. So I'm going to choose the y equals 2x plus 8. So y equals 2 times a negative 5 plus 8. Y equals, so that's a negative 10 plus 8. That's going to be 2. No, negative 2. Sorry, negative 2, right? Negative 10 plus 8 would be negative 2. So y equals negative 2. So my ordered pair that describes the intersection of these two equations is negative 5, negative 2. Now I'd like to check this, and we have two ways we can check it. I know that it'll work in the first equation because I solved for it there. I would want to verify that it works in y equals negative 5x minus 27. The other way to check it is to put both of these equations into your graphing calculator, graph them, find the intersection, and see if indeed it is at negative 5, negative 2. I'm going to do a quick substitution here. You might want to go ahead and try doing it in your graph, but I'm going to put in negative 2 equals a negative 5 times a negative 5 minus 27. So negative 2, negative times a negative is a positive, is 25 minus 27, and a negative 2 equals a negative 2. It checks. Need to make sure it works in both equations, but if it does, I can check it off and move on. Let's look at our next problem here. This is a problem in context. The online catalog Sock Puppet will charge you $3 for shipping and handling plus 50 cents per pair of socks you order. The Foot Glove catalog will charge you $3.90 for shipping and handling plus 40 cents per pair. How many pairs of socks would you have to purchase to make the costs equal? So what they're asking us here is the total charge for your order. So I'm going to use, we'll just make that cost, right? C, I'll make it C sub S for sock puppet. It's going to be the same C when we go to solve this, but I just want to make sure I have this laid out. It's $3, that's a fixed charge, plus $1 or plus 50 cents for your socks. That's a pair of socks. 50 cents per. Okay, and then C sub F is equal to $3.90 plus 40 cents times the number of socks. This is our system of equations. Now we want to go in and solve it. We can do this by substitution. And they want to know how many pairs would make this equal, so that's saying that these two equations equal each other. And so I'm going to go ahead and create my expression. I'm going to use the C sub S1 as my value. Since C equals $3 plus 50 cents times S, then that means that $3 plus 50 cents times S is equal to $3.90 plus 40 times S. Now I'm going to solve for S. I think I'm going to put the S's on the left and the dollars on the right. When I subtract 3 from $3.90, I get 90 cents. I'm going to subtract 40S from 50S, and that'll leave me with 10 cents times S. I'm going to divide both sides by a tenth, and 0.1 into 0.1 is just S. How many times does a tenth go into 90? Oh, that goes in 9 times, so S equals 9. Okay, now we want to verify that this works for our system, but we seem to have answered the question. How many pairs of socks would you have to purchase to make the costs equal? This would seem to indicate that we're done here. To check it, we would have to plug this back in, S back in for 9, find C, plug C and S into the other equation and see if it works for both of them. Or we could set these up, graph them both, and look for the intersection and see if it is at S equals 9. Okay? So those are your choices for this problem. Let's look at our next one. Okay, example 3. Tortoise challenges a hare to a 10-mile race. The tortoise moves at a steady speed of 0.2 of a mile per hour. The hare can move at a speed of 40 miles per hour. Because the tortoise is slow, the hare decides to wait until the tortoise is 1/4 of a mile from the finish line before it even starts the race. Can the hare still win? Okay, so what this is telling us, for the hare, the distance travels, the D is equal to 40 times time. So that's 40 miles per hour times time. Since the hare is giving the tortoise a 9.7 mile head start, right? It's waiting till it's 1/4 of a mile from the finish line. We need to know what it'll take for it to catch up. So this is going to be the distance for when it's traveled 9.75 plus the hare's speed, 0.2 t. Okay. So this is what we want to know. So basically the hare doesn't start until the tortoise has arrived at 9.75 miles. That's the beginning of time, 40t. And then the tortoise continues on. So since these both equal d, we'll do our substitution and say that 40 times the time for the hare is equal to 9.75 plus 0.2 times t, the tortoise's speed. So this will give us a chance to solve and see what our t will be and see if can the hare still win. So we'll solve for t. I'm going to subtract 2/10 from both sides of the equation, and 2/10 from 40 would give me 39.8 t equals 9.75. So t, if I divide both sides by 39.8, would be so the time is about 0.2444975, and this is hours. So this means that after the run has been running for this 2.44975 hours, the hare has run a certain distance. Well, how far is that? I'd like to know how far it's run. The question is can it beat the tortoise to the finish line? So I'm going to plug this back into the 40t calculation and see what that distance actually is. So d equals 40 times 0.2444975. And that tells us our distance is about 9.8 miles. Can the hare still win? The answer is yes. Since the race is 10 miles long and the hare will have covered 9.8 miles to catch up to the tortoise, it then has 2/10 of a mile to get ahead and win the race. So the hare wins. All right. If you had a different approach, love to hear about it if it works. If you have a different approach and it didn't work, then try a different approach, try this approach. Remember, you got to kind of read through the problems and figure out what it's asking you to do. Guided example 3. Bart was so confident he could run faster than his little sister. He bragged, "I can beat you in a 50-meter race. I'm so sure I'll give you a 10-meter head start." Well, this looks an awful lot like the example we just went through when we did this with the tortoise and hare problem. So let's go through this again because I think it's worthwhile to review the just setting up of these types of problems. Could Bart catch up to his sister before the end of the race? Not too different from the tortoise and hare. We got to figure out, so the distance that Bart and his sister have traveled after t seconds, and remember distance equals rate times time. So for Bart, d equals 4 times t. That's 4 meters per second times however many seconds they were running. He's given his sister a 10-meter head start. So her distance is equal to 10 plus 3 times t. So because she's ahead by 10 meters. To know the time when Bart will catch up to his sister, solve the system. So what system are we going to solve here? Well, we know that d equals 4t. That's our first equation. What's our second equation? d equals 10 plus 3t. The head start plus 3 times the sister's time. We're going to do our substitution. Substitute 4t for d in the second equation. So we get that 4t equals 10 plus 3t. We're going to solve the equation. We're going to subtract 3t from both sides, and we're going to get that t equals 10. This means that after 10 seconds, Bart and his sister are at the same point. Is the race finished at 10 seconds? We substitute 10 to find out the distance. We'll do that into 4t. 10 times 4, so 4 times 10, so d equals 40 meters. The race is 50 meters long. So Bart not only can catch up, since he's moving faster, he will pass his sister. Hey, that's it for 10-2. Hope it's helpful for you. See you. Good luck on the mastery quiz. See you in class.